Okay, welcome to video the static and dynamic dispatch in Rust part 2. If you are watching this part 2 without seeing the part 1, I request you to complete the part 1 and come to this video. Okay, let us start the video. Sometimes we encounter a situation where our types may increase with the passage of time, and therefore we need to keep room for those types which may evolve later on with respect of time. This means we need to have some flexibility in our code so that it can easily adapt to new evolving types. The dynamic dispatch provides a perfect solution in this regards. I will comment out the code and we will start afresh again. Yeah, this program was based on a print trait which contains a print function. We have two types of i32 and string which implements this trait. And finally, we have a display function which accepts any type which implements the print trait and is used to call the print function. Now, from the previous discussion, we know that this function is doing a static dispatch. So let me rename it. In this main, I will change the name of the function accordingly in the call to the function. Now, what I want is to pass a vector containing different types to the function and get the values to be displayed. Since the generic can assume a single type, therefore the static dispatch will not work here. This is because the generic will be resolved to a single concrete type during the compilation. This can be done using the dynamic dispatch. I will define another display function which will essentially do the same but using the dynamic dispatch. In the input to the function, I will mention a vector of trait objects since I want to pass in a vector containing different types to this function. This now means that x is a vector of any types that has the trait print. In the body of the function, I will iterate through all the values of the vector x and will display its values. In the main, now I can call this function with a vector containing different types. Please note that we need to pass in references to values and not concrete values. Let us cargo run this. You may note that the compiler has no issues. This is one of the main use cases of trait objects. That is, it allows for defining vectors of having different values with a possibility of extending the types inside the vector in future. We know that the trait objects are referenced to traits and they can be created using either a simple reference, a box, an arc, or RC smart pointer. So, let us redefine the function display underscore dynamic using the box smart pointer. I will wrap the drain print inside a box and will delete the simple reference. In the call to the function in the main program, I will wrap the values of the vector inside a box and will delete the references. You may note that this compiles fine. In the same way, we can use the arc or RC smart pointers to create the trait objects. Okay, in summary, it is very efficient to use static dispatch when the underlying types are not many in numbers. The standard library also generally tries to statically dispatch wherever possible. However, when the types involved are many, we would like to do a dynamic dispatch. The static dispatch is made possible with the help of the monomorphization, while the dynamic dispatch is made possible with the help of trait objects. Okay, with this we end this part and meet you in the next video. Until then, keep in touch with the Rust, and if you enjoy this video, please like, share and subscribe to my channel and have a good day. Bye bye.